Okay, so for the next presentation, I would like to invite Miss Nathalie Gloria with the presentation code SEE-02. The presentation title is Bioethanol Production from Oil Palm Fronds Biomass Waste. Miss Nathalie Gloria, you can start your presentation now. Your time is 10 minutes. Thank you.
Okay. Thank you, Ms. Dia. Can you see the presentation now? Is it clear?
Yes, you can see your presentation.
Okay. So good morning, ladies and gentlemen. Thank you for the opportunity that is given to me to present the result of my paper with the title of Bioethanol Production from Oil Palm Fronds Biomass Waste Review. Before we begin, I would like to introduce myself. My name is Nathalie. I'm a Swiss German University bachelor degree graduate, and Dr. Evita and Dr. Irvan is supervising me on making this paper. Here we go. As we all know that Indonesia is the leading country of palm oil producers, and with the growing concerns about the depletion of oil, finding alternative resource has led to a growing interest in both idea of sustainability and renewable energy. Indonesia reaches a total area of 12.5 million hectares of plantation. And from this 12.5 million hectares of plantation, a huge amount will be generated as well. Indonesia is estimated to produce 146.7 million tons of biomass waste per year. And the biggest solid waste comes from oil palm frond. It accounted to 61% to the overall palm oil biomass waste. But oil palm fronds still receive less attention compared to the other biomass. It is usually being left as a waste in the natural environment, or it becomes a fertilizer around the plantation. Instead of leaving it as a waste, it is better to make use of oil palm frond to become a renewable source of energy. It could be a substrate to produce bioethanol because of its high sugar content. And then furthermore, the development of bioethanol in Indonesia is not as good as the implementation of biodiesel due to the lack of bioethanol raw material. So this research was actually planned to be a laboratory-based research, but COVID-19 happened, so the methodology is modified into a literature review. And this is the flowchart of how the literature review should be implemented in this research. Firstly, there are 3 types of palm oil waste that can be converted into bioethanol. There are oil palm trunk, empty fruit bunch, and oil palm frond, and we are focusing on oil palm frond in this research. And then there are 2 methods to utilize oil palm frond as a fermentation substrate to produce bioethanol. First method is using the dried oil palm frond, and another method is using oil palm frond juice prior to fermentation using yeast, which is Saccharomyces cerevisiae. And then there are 3 variables studied in this literature review. There are pH, time, and temperature. And then afterwards, discussion and analysis can be made. So from all the reviewed literature, there are 3 types of palm oil biomass waste which can be converted into bioethanol. There are empty fruit bunch, oil palm trunk, and also oil palm frond. But among these 3 types of palm oil biomass waste, oil palm frond is the simplest and the most inexpensive material to process compared to the other 2 biomass, because empty fruit bunch and oil palm trunk still requires various pre-treatments, and in addition to that, enzymes need to be used to convert the cellulose into sugar. So the overall process not only contributes to a high cost of sugar production, but it also causes the proper wastewater pre-treatment, since there are a lot of chemicals are being used in this process. So furthermore, there are 2 methods to utilize oil palm frond as a fermentation substrate to produce bioethanol, using the dried or the juice. So to obtain the sugar from oil palm frond fiber or the dried oil palm frond is involving the conversion of cellulose and hemicellulose into glucose and xylose through a hydrothermal treatment followed by enzymatic hydrolysis. So this method still involves the use of high temperature, high pressure, and also the need of cellulose enzyme. So the overall process is also costly, and it consumes a high amount of energy. Therefore, there is an alternative approach where the production method does not require harsh pre-treatment steps and no need the use of enzymes by just simply pressing the frond to obtain the juice and then ferment the juice obtained with Saccharomyces cerevisiae. With this simple procedure, a lot of costs can be saved, such as equipment costs and chemical expenses for pre-treatment processes are not necessary. So from the literature reviewed in my study, utilizing oil palm frond juice is more preferable than using the dried oil palm frond because it can be obtained easily. The method is cost effective. Also, it is proven by Lee and Halim on 2014 that oil palm frond juice consists of approximately 650 grams per liter of the overall free sugar. It consists of glucose, fructose, and also sucrose. Besides this, utilizing the juice from oil palm frond as a fermentation substrate is very advantageous due to its renewability. It is inexpensive and it's available abundantly in Indonesia. So the simple step on converting the juice into bioethanol consists of fermentation with the help of Saccharomyces cerevisiae, and then next distillation to make purer ethanol, and then bioethanol was made. Also, Saccharomyces cerevisiae is more preferable than the other yeast because according to a study from Cannes on 2013, Saccharomyces cerevisiae is the best yeast for conducting fermentation because it produced twice ethanol yield in comparison to the other yeast. So this is the table showing a fermentation condition comparison between 5 experiments conducted from the literature reviewed in my study. So mostly the pH ranges from 4.4 until 6, and the temperature ranges from 30 degrees Celsius until 37 degrees Celsius, and the fermentation conducted varies from 24 hours until 96 hours. All studies were done without additional nutrients, but study number 3 and 5 were optimized. It was optimized using a design expert version 7 program where a central composite design was employed, and then the central point of each process's variable was chosen based on the best condition obtained from one factor at a time method. But as we can see, study number 1, 2, and 4 were done without additional nutrient, and also without optimization, but it can still produce bioethanol. This shows that fresh oil palm frond juice itself can be a complete fermentation medium for bioethanol production without the additional of nutrients or optimization. Also, the bioethanol concentration can be very various because the pH, temperature, and time used for the fermentation were all different, but also the bioethanol concentration will also affected by some external factors. The quality of oil palm frond juice is influenced by 2 other external factors, which is the position of the frond and the age of palm oil tree. First, the location of the frond. This is a study according to Yamada on 2010, shows that the frond that is directly connected to the inner part of the oil palm trunk most likely has higher sugar concentration than the other fronds. This is because the inner part of the trunk has been proven to have the highest sugar content compared to the intermediate or the outer part of the trunk. And also, according to a study from Srimakai on 2015, from the literature review, it shows that the volume of oil palm frond juice and the sugar concentration significantly decrease inversely proportional to the age of palm oil trees. From the experiment conducted, the highest sugar concentration in palm oil tree is the age between 3 until 4 years old, compared to the trees with the age of 5 until 25 years old. The younger the palm oil trees are, the higher the concentration of sugars they have. So it was concluded in my literature review that oil palm frond might be the best biomass waste from palm oil tree for bioethanol production compared to empty fruit bunch and oil palm trunk. And to produce bioethanol from oil palm frond, there are several factors that influence it. First is the age of palm oil tree significantly affects the concentration of sugar. So when the age of palm oil tree increases, the concentration of the sugar is reduced significantly. Also, the frond that is connected directly to the inner part of the trunk apparently has higher sugar concentration compared to the other fronds. Then the best method of utilizing oil palm frond as a raw material in producing bioethanol is to obtain the juice and then ferment the juice obtained with Saccharomyces cerevisiae. Furthermore, there are several conditions such as pH, temperature, and fermentation time that influence the bioethanol production.
Check. Okay, I think we are losing Nathalie Gloria, but since actually I think that the presentation was already finished, but she had also declared the conclusion of her study. So while waiting for for Nathalie Gloria to rejoin for the Q&A session, probably we can gather the questions first from the participants. And when Ms. Nathalie Gloria can rejoin us, then we can start the discussion and the discussion session. Or yeah, I can probably also invite one of the co-author of the study, Mrs. Evita Legowo, to share a little bit about the state of bioethanol research in Indonesia. Ms. Evita Legowo, how is it actually now? Is it increasing in the progress, or what's actually the biggest trouble that has been the challenge of the innovation of bioethanol in Indonesia? Yes, Miss, can you please unmute first? I think you are still muted. Oh, host can, yeah.
Thank you, Ibu Dia. Yes, actually, for me, especially as an energy people from this side, that until now is a little bit sad, because if biodiesel can really moving forward, but for the bioethanol it is so difficult because we are lack of the feed, yeah, lack of the raw material. So that's why this research is try to find out ways that still contain a lot of sugar, and then we can try to move to be a bioethanol in Indonesia, because we know that now we still have a lot of we still imported gasoline, and without any additional bioethanol, it will be need a lot of money also. So I hope that this research actually can be continued and can be followed up with the higher scale, and hopefully we can be implemented also commercially. This is my hope. Yeah. Thank you, Ibu Dia.
Thank you, Ma'am Evita. So for the others probably who might have questions, this is a rare opportunity. We didn't really plan Ma'am Evita to actually join the discussion session. But if you have any questions, you can also, as usually, write your questions in the chat room. We still have several minutes. Yeah, so probably I would ask a little bit about this research, Ma'am Evita. So as I noticed that you have been actually very much scrutinizing the opportunity to make use of the waste of oil palm plantation or palm plantations. And is it now with the palm fronds, do you have like the sense of this is going to be more promising than making use of the other parts of the palm plant or the other parts of the tree? Is the palm oil or palm fronds is going to be more promising to be utilized? What do you think?
Yes, actually, for me now, actually, my next research now is I try to find out about the oil palm trunk also, because oil palm trunk is also we have a lot also, and this actually we can use nothing about it, yeah. So it's only just for maybe for fertilizer, but it's also a lot of work has to be done in the oil palm trunk because it is harder than oil palm frond. But actually, this is the opportunity that we can use waste to be something that more useful. And to be frank, I would like really, I hope that if the pandemic is not anymore there, so we hope that we can do it, we can try it in the laboratory, and then I hope that we can hire the scale. Yeah, so this is my hope. But yes, from now is maybe for me is two actually it is most promising. The first is the oil palm frond, and the other is oil palm trunk. Because with that, the database is still empty fruit punch, for example. This we can also convert it to be bioethanol, but empty fruit punch can be used for other energy. Thank you, Budia.
Okay. Thank you, Bu Evita. Now we have several questions. If you would, we still have like around 3 minutes, and we would like to try to read several questions first. Ibu, is there any trial or experiment applied in car or public transport using bioethanol that it can convince its benefit to public? From Mr. Setiadi.
Yeah, actually bioethanol, yes, we already because before I work in Lemigas, and we already started to try it in the transport in the car, but it's not really in the public transport yet. Yeah, and in Indonesia actually we have also already implemented bioethanol. I think until in the year 2007, 2008, and 2010 we already implemented actually until 2%. Yeah.
Okay.
But and then after that, because we don't have any more, the raw material is not enough. So then I think Indonesia stopped trying it 2011 or something. We already tried to use it in Indonesia I think from 2007 to 2010.
Okay. I think that also relates with the second question from Dr. Yuti, that this approach has been adopted in any company on your experience. Probably it has been, but not the exact method that Miss Nathalie Gloria presented, probably. Yes, Bu?
Yes, it is. Not yet from the oil palm frond, but we already used the bioethanol in Pertamina before. It's not a lot, but we have started to do it, but not from oil palm frond. We have to do more research, I think laboratory research to know better about oil palm frond to produce bioethanol.
Okay. The collaboration to industry with industry, yeah, that was the same. Yeah. The related question. I think then for this method, not yet from oil palm frond, yeah, not yet collaborated with. How about the availability of the OPF to be used as raw material of bioethanol?
Yeah, OPF is actually we have a lot. You know that is so we have a lot of oil palm plantation in Indonesia. We are the biggest CPO exporter in the world. So of course the waste is also a lot. So I think it is also possible to have the. I would like to answer directly to the from Pak Henry here. How about sustainable raw material? Yes. For me, it will be until now. It will be sustainable if we use OPF, yeah, oil palm frond. And also, may I direct answer from the Pak Sigit Haryono, Ibu Dia?
Oh yeah.
Yeah. Pak Sigit Haryono asking about will be the best production. Are you analyzing the freshness forms? Yes. there is it's not yet been done. How about the freshness? Which one is the best? So, but I think for the next from the next visit, we will go there. We will go. Which one is? How about the freshness of the palm frond? We will go there. It's not really yet. We don't know yet the result, but we will go there.
Yes.
And from Ibu Yuti, do we have collaboration with industry? As from OPF, it's not yet. But I think it will be easy if we can do that. But of course, before we work together with the industry, I think we have to go to the laboratory first. So I'm not really confident enough, if not yet in the laboratory and then going to the industry.
Yeah.
So thank you, Ibu Dia.
Thank you, Bu Evita, for the discussion about the research, and we hope that the pandemic will be over soon, so the research in the laboratory, the experiments can be done soon, so we can have more results about your idea in utilizing the oil palm frond. Thank you very much, Bu Evita.